In this lesson, we're going to talk about a quadrilateral that is not a parallelogram. We've been talking about parallelograms, and today we're going to talk about quadrilaterals that are not. What makes trapezoids different is the number of sides that are parallel. For parallelograms, both pairs of opposite sides are parallel. For a trapezoid, only one pair of parallel sides. So all trapezoids have one pair of parallel sides. Those are typically marked with arrows. It doesn't have to be turned this way, so don't be shocked when you see one that's turned sideways. Those two lines, those two parallel lines, do not have to run horizontally. They can run vertically or diagonally or however you want, but you're going to have only one pair of parallel sides. And then the non-base angles are supplementary. What that means is non-base angles that don't match up. Like these are base angles, these are base angles, and these are base angles. Okay, so our non-base angles are supplementary. And the reason is because they are same side interior angles. So these two equal 180. They are supplementary. And these two over here. Now don't get confused. What a lot of people want to do is they want to match these two up and make them be supplementary. But they have to join together across the transversal. The transversal is what joins those parallel lines together. So these two add up to 180 degrees. These two add up to 180 degrees, but not this way, not along the parallel lines. It's between the parallel lines, not along the parallel lines. Then we have a special trapezoid that has the legs that are congruent. So these are the legs, and then these are your bases. So these are your legs. So what happens is when those two legs, the distance between those two parallel sides becomes the same, it causes those diagonals to be congruent. So this diagonal here that goes from corner to corner is the same length as this diagonal here. And then also these base angles. So these base angles are congruent to each other, and these base angles are congruent to each other. So they're already supplementary, but now they're congruent. That is not the case here. These two angles are not necessarily congruent to each other, and these two angles are not congruent to each other. Unless these two legs, unless these two sides are congruent like they are here, that does not happen. They're supplementary, but not congruent. So if you look at a problem that looks like this, we have these two parallel sides. I'm talking about the angles, and I want angle K. Here is angle K. Angle K is right here. Now, this is not an isosceles trapezoid, and so we don't have congruent base angles, but what we do have is we have that this angle and this angle, those are same side interior angles, which means they are supplementary. So you can take 180 and subtract 51. You get that angle K is 129 degrees. So this is 129 degrees. Then I want angle M. Angle M is on the other side. And in that case, these angles, right, they bridge the gap between the two parallel lines. So this angle J and this angle M, they are same side interior angles, which makes them supplementary, which means that you would take 180 and subtract 87. And you get 93. So this is 93 degrees. So in this case, we've got our same side interior angles, or our consecutive interior angles. Same side interior equals 180. They're same side supplementary is what we always said. Okay, so let's look at question 2. Again, we're talking about the angles of a not special trapezoid, just a plain regular old trapezoid. And what I notice is that B and C are consecutive or same side interior angles. So what I know is that those two add together to equal 180. They are supplementary. So I'm going to add those two together. 9x plus 2 plus 5x minus 4 is equal to 180. 9x plus 5x is 14x. 2 minus 4 is minus 2, and that equals to 180. You go through, add 2 to both sides, and divide by 14. And you get that x is 13. Once you know that x is 13, I asked for angle B. So we come up here. I know 9 times 13 plus 2. So 9 times 13 plus 2, we substitute that in, and we get 119 degrees. It looks like this on the calculator, 9 times 13 plus 2. And then angle C. You can either, if you trust yourself and you trust that you got 119 correctly, you can just subtract that from 180, or you can substitute it in if you're not comfortable. And you get 5 times 13 minus 4, and you should get 61 degrees. And look, those two add up to 180 degrees. Now, there is no way for me to find out anything over here with these two because these two do not relate to these two angles over here. B and C, when it's not isosceles, B and C do not relate to A and D. Now, number 3, this one, notice this is isosceles. So when this is isosceles, things began to behave differently. So that's when we get our congruent angles. When we have congruent sides, we have congruent angles. So what that tells me, so first I want Q. So I know that base angles are congruent, so P and Q are equal to each other. So Q is 112 degrees. Then I need angle S. Well, I got to figure out how to get there. Well, I'm going to travel this transversal between those parallel lines. Those are consecutive interior angles, or my same side supplementary angles. And so I can take 180 and subtract 112 and get that angle S is 68. Then angle R is either the same as S or it's supplementary to angle Q. So whichever way you want to look at that, you can see that angle R is 68 degrees because base angles are congruent and side angles, right? Not because they're on the side, but your same side interior angles are supplementary. Okay? Then lastly, we have MNOP is an isosceles trapezoid. If PN, so we need to notice what PN is. PN is a diagonal, is 5y plus 19, and MO, that's the other diagonal, then is 12y minus 37. Solve for y, PN and MO. Well, what I know is that the diagonals are congruent. Because those sides are congruent, the diagonals are congruent. So that means part equals part. I set them equal to each other. 5y plus 19 is equal to 12y minus 37. Subtract 5 from both sides, 5y, add 37 to both sides, and you get 56 is equal to 7y. Divide both sides by 7 and you get that y is 8. If y is 8, Pn is 5 times 8 plus 19, so 40 plus 19 is 59. Which means that MO is also 59, and you can double check that by substituting it in. If they don't match, then something might be wrong. So trapezoids are one pair of parallel lines. They don't have the same qualities that parallelograms do. Only when you get the only special quality about trapezoids is that your non-base angles or your consecutive interior angles are supplementary. And then once your sides become congruent, your diagonals are congruent and your base angles become congruent.